Roof gutter design. We will take one example to design the gutter and the downspout or the collection pipe. Okay, so to size the gutter, we have an example. Design a roof gutter and a downspout. For the given example, we have to assume the runoff coefficient because it's a roof. So for roof, the runoff coefficient is 0.8 generally, and rainfall intensity for this location is 60 mm per hour. Okay, so we have the I, that is the rainfall intensity. We have the runoff coefficient, that is 0.8. What will be the first step? Step one will be to calculate the catchment area. Okay, so in this case, it's a sloped roof. Okay, and you have the dimensions, you have the length and width of this roof. So you can directly calculate. Okay, 5 into 20, that is 100 square meter. You can also use that lengthy formula, like uh, area of the horizontal plane plus 50% of the vertical elevation. That is also okay, but this formula is also okay if you know the dimensions. Okay, the value will not that much vary. Okay, so you have the area that is 20 into 5, 100 square meters, the catchment area from where you are collecting the rainwater. Step 2, calculate the stormwater runoff in GPM. How much water will be collected from this sloped roof? So we have a formula that we have studied: C into I into A divided by 60 into 16 to 1000. We have C, that is runoff coefficient 0.8. We have rainfall intensity, that is 60 mm per hour, and A is the catchment area. In the first step we have calculated, that is 100. We have put it all the values and we get 0.0013 meter cube per second, but we need in GPM. Okay, so to calculate in GPM, multiply with this 15,850 to meter cube per second, you will get 21.3 GPM. So 21.3 GPM is the flow rate of water from the sloped roof. Okay, this is your step 2. Step 3 will be determining this gutter size. Okay, what will be the size of this gutter? Now you know the catchment area, you know the GPM that will be flowing from the sloped roof. The third step will be to calculate the gutter size and slope. This gutter will not be in the horizontal position. It will be having some slope to flow towards the collection pipe, in order to flow of the water. So we have to determine the gutter size and slope using table 1106.6 IPC, International Plumbing Code. Okay, so according to that table, we get gutter width 1.5 inches, gutter depth 2.5 inches, and gutter slope 1/4 inches per feet. Where is that table? Okay, so see, we have the dimensions is 21.3. So this is the table 1106.6. We have gutter dimensions, we have slope, and we have the capacity. Okay, so in our case the capacity is 21.3, so it will be the 26 we have to take. So for 26, what is the size is coming? 1.5 and 2.5. Okay, so these dimension is for the rectangular channel. So gutter will be in the rectangular shape. Okay, so it is giving in the rectangular shape, and slope it is giving 1/4. Okay, so now in this case, if you want to do for the semicircular one, you can easily find out the cross sectional area and you can convert in the circular one. Okay, just I'll give you a way how you'll do this. You have a rectangular sizes, width, sorry, this is the width, and this is your depth, width into depth. Okay, so the cross sectional area will be width into depth, right? And cross sectional area for the circular one will be pi r square. So once you know this value, you can calculate r, right? So you must know the cross sectional area. Either it is a rectangular or it's a circular, semicircular. Okay, so that will be easily calculated. So as per the IPC, for 21.3 GPM, you must go with the rectangular gutter. Okay, and in this table somewhere you see they have given only one dimension, 4 inches, 5, 6, 8. So as per IPC, for 39, a round, that is a semicircular gutter, is recommended. For 74, 5 inches, that is for 74 GPM, round one is recommended, that is semicircular one. So this is as per the IPC recommendation. But if you want to calculate as per your requirement, as in this case we have a round one, you can calculate the cross sectional area and convert into a semicircular one. Okay, so this is about the step 3 to identify the dimensions of the gutter and the slope. Okay, what will be the step 4? Step 4, to determine the downspout size. Okay, this rainwater downpipe using table 1106.3 IPC. Okay, so based on this table, we get the size as for 21.3 as 2 inches. Where is that table? Table 1106.3, vertical liter sizing. This downspout we also call it as vertical liters. Okay, so for 2 inches, for 21.3 will go with this one. Okay, so we have a 2 inches. Okay, that will be the diameter of this uh, vertical leader.